Well, let's continue. Let's make this graph a little bit more beautiful. Um, Moment. Um, you can add uh, the, well, basically this is a good model. Of course, this is the quantity, and here you have cost revenue. Basically, um, well, the optimum point is here, the point at which the marginal revenue curve and marginal cost curve, which is a gray line, will intersect basically. Um, uh, well, you don't need to do this, but just for fun, let's a little bit zoom on the optimum point. Um, um, okay, let's take this 0 and let's take this 5,000. So, and you can also do the same thing here, 1,000 to 3,000, and you can see here actual intersection point. I mean, if you zoom there. Okay, well, this type of a well, uh, this type of a graph can maybe okay if you especially draw with your hands. Although, of course, in this type of assignment, I ideally want a graph which shows all the values for a whole range at x and y axis. But for the approximate graphs, this is okay. If I just want to show you, I mean, for example, show me how we on the graph how marginal revenue, how the optimum point is found. Optimum point is found by looking to the intersection point of MR and MC curves. Anyway, let's take backwards. And now, actually, one thing you can do is take this 1000 and minus 1000, which is certainly better. Okay, and also for this one, you can add that 40,000. Okay, now draw the graph for monopsony case. Assume the quantity, optimum quantity the company employs is 18,000 workers, which means the amount of steel produced is 1,800. Assume wage paid for these workers is $75 per day. The cost will be $750. Since you need to employ. Actually, the cost will be higher because you have more workers. What is the rate of exploitation? Well, for 100 units, you look to the margins, of course. For the last 100 units, the cost will be 750. So first, of course, this case one is not anymore relevant, so you can forget it. This is the amount you produce, so this part is relevant. And basically, your marginal cost is always, in this case, no, for this last unit, in this case, I mean, 750. Now, this is not marginal cost. I'm sorry. You cannot find the marginal cost. You need to look the whole table. But the wages, the average cost in this case, is equal to $75, which is equal to wage also. So, in order to not have the exploitation, basically, the wage should be equal to the marginal revenue brought by the workers. Of course, But since you have 10 workers, basically, this is 750 for last 100 units. So 750 is the cost of the last 100 units. The revenue brought by the last 100 units is $1,500. So the exploitation is, in this case, the difference. Well, here I did not ask you to create the case also for the case 2 for the Monopsony market. But I have already shown you how monopsony market case could be created in the example in the previous parts. So I think also you should be able to do that. It's not that difficult actually. And the graph will be. I think I don't need to draw the graph. Basically, the graph will be just like this. Let me show you. Like this, which is also drawn by Excel, by the way. Well, the difference is this will be 750 basically. No, this is you want, but this will be 1,500, since marginal revenue should be equal to marginal cost. So marginal cost is also 1,500. The wage is equal to 750, and average cost will be equal to average revenue will be equal to 5,750. So you will have this will be 5,750, this will be 750, and this will be 1,500, and the quantity of the labor force will be equal to 18,000 basically. The quantity here. You need to draw just roughly. I mean, all the numbers should not be there. So this is how you solve this question. And this is pretty much this week's lecture. See you in the next lecture, and I hope all of you will stay healthy.